Question 22. The area of a semicircle is given by A equals 0.5 pi r squared, where r is the radius in inches. The semicircle displayed on a computer screen is increasing in size, and its dimensions are measured over a period of t seconds. Part A. If the semicircle has an area of 6 pi square inches and its radius is increasing at a rate of 0.25 inches per second, at what rate is the area changing? So this is a question that I want to answer, and I'm going to start right there. It says, at what rate is the area changing? So I would like to know, what is dA dt? Okay, I'm going to go ahead and write down some other information they give me in the problem. They did tell me that the area was 6 pi. And then they did also tell me the radius was increasing at a rate of 0.25. So that would be dr dt, and that would be 0.25. Okay, we have learned in these problems that once I have my information, we want an equation, and they gave the equation right up in the setup of the problem. And then once I have my equation, I would like to take the derivative. Well, the derivative of a with respect to time would be dA dt. And then the derivative of the right side, I'd bump my 2 out front. 0.5 times 2 is 1, pi r. And then I do have to remember to include dr dt because we are taking the derivative with respect to time for all parts. Okay, now from here, if I plug in what I know, I do know that dr dt is equal to 0.25. Okay, but I do not know what r is, so I do need to do a side trip to find r. I do notice that we know what a is, so if I come up in this equation right here and plug a in, I should be able to solve for r. So I'm going to have 6 pi equals 0.5 pi r squared. I'm going to divide both sides by 0.5 pi. I notice that my pi's will cancel out, and then 6 divided by 0.5 is 12. So then to get rid of the square, I'll take the square root of both sides. So r is going to equal the square root of 12. So here we'll have dA dt is equal to 1 pi times the square root of 12 times 0.25. And I actually came up with an answer for that, and I found out that my answer was 2.721. And it said, how fast is the area changing? If my radius is measured in inches, the area would be measured in inches squared per second. So that would be my answer for that part. Okay, part B, if the area of the semicircle is increasing at a constant rate of 8 square inches per second, is the radius of the semicircle increasing more rapidly when the radius is 2 or when the radius is 3? So I would like to know where is the radius increasing more rapidly? So I know that I'm wanting to find something out about dr dt because that's how fast the radius is changing. Okay, I'm going to write down information for my problem again. It says the area is increasing at a constant rate of 8, so I know that dA dt is equal to 8. And then my radius, I actually have to compare. My radius is either going to equal 2 or my radius is going to equal 3. I'll have to use both of those and decide which one gives me the semicircle increasing more rapidly. So once again, I do have a formula. A equals 0.5 pi r squared. If I take the derivative of this, I'll get dA dt is equal to 1 pi r dr dt, just like we did above. Okay, now I need to do some comparisons. If r is equal to 2, I'm going to have dA dt as 8, and then I'll have 1 pi times 2 dr dt. Okay, to get dr dt, I'll do 8 divided by 2 pi. Please remember when you do this on your calculator, put the 2 pi in parentheses, and when I do that, I'm going to get 1.273 inches per second. Okay, and then when I let r equal 3, I'll get 8 equals 1 pi times 3 dr dt. If I divide both sides by 3 pi, I'll get 8 over 3 pi is equal to dr dt. And again, if I use my calculator, making sure my 3 pi is in parentheses, I'll get 0.849 inches per second. And then the question was, is the radius of the semicircle increasing more rapidly when the radius is 2 or when the radius is 3? Well, I see for 2, my dr dt is bigger, so I will say, hopefully I can fit this in here, the radius is increasing more rapidly when r equals 2 inches, and the reason would be because dr dt is larger.